Right now, as you are watching this, a rocket is being built that could change the entire trajectory of human civilization. It's called Starship, and if everything goes to plan, the first uncrewed version of it will touch down on Mars before 2027. That's not science fiction. That's the actual schedule. But here is what nobody's talking about. Even if the rocket works perfectly, living on Mars might be one of the most brutal challenges our species has ever attempted. Today, we are going to be honest about all of it. Let's start with where we actually are. SpaceX has announced plans to send 5 uncrewed Starship rockets to Mars during the 2026 launch window. That's November and December of 2026, when Earth and Mars are aligned just right. Each ship would carry about 22,000 pounds of payload, including Tesla's Optimus humanoid robots, which would begin testing hardware and scouting the landing site. Elon Musk himself puts the odds of hitting that window at 50-50. Those aren't great odds. But here is the thing, even a 50% shot at landing something on Mars in 2026 would be historically unprecedented. The target landing zone? A place called Arcadia, Planitia, a volcanic plain in Mars's northern hemisphere. Why there? Subsurface ice sits just a few inches below the surface. The ground is flat, and mid-latitude sun exposure is strong enough to power solar panels. If the uncrewed missions succeed, crewed missions could follow as early as 2029, though 2031 is considered more realistic. And then it gets big. The roadmap calls for 20 launches in 2028 and 2029 to build out infrastructure. By 2031, potentially 100 launches. By 2033, 500. The goal is a self-sustaining colony within 30 years. Now, let's talk about what Mars actually is, because the romanticized version, the red, dusty world, doesn't quite capture the reality. The average temperature on Mars is -80 degrees Fahrenheit. That's roughly the same as the center of Antarctica in winter. On bad days, it drops far lower. The atmosphere is 95% carbon dioxide. Oxygen? Just 0.13% compared to 21% here on Earth. And the atmospheric pressure is less than 1% of what we experience at sea level. Step outside without a suit and your blood would literally start to boil. But the biggest invisible killer is radiation. Earth has a magnetic field that deflects harmful cosmic rays. Mars doesn't. Settlers on Mars would be exposed to roughly 700 millisieverts of radiation per year. For context, an X-ray gives you about 0.1 millisieverts. That's a dramatically higher cancer risk. And get this, there is no short-term fix. Shielding habitats with Martian soil helps, but designing a suit that's thin enough to work in and yet stops radiation? That's still an open engineering problem. The gravity is 38% of Earth's. Nobody knows the long-term effect of living at that gravity level on human bones, muscles, and organs. We simply don't have the data. Here is where things get genuinely exciting and where NASA has already proven something remarkable. On the 18th of February, 2021, the Perseverance rover landed on Mars. On board was a small gold box experiment called MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. Its job? Take Martian air, that 95% carbon dioxide, and convert it into breathable oxygen. And it worked. Not only that, it produced 12 times more oxygen than initially expected. That proof of concept is massive. Because if you can make oxygen on Mars, you can make rocket fuel on Mars. And if you can make rocket fuel on Mars, you don't need to haul it from Earth. Suddenly, the economics of the whole operation change completely. Water is the next piece. Mars has enormous reserves of subsurface ice, particularly at mid-latitudes. In Arcadia, Planitia, the planned landing zone, ice sits just a few inches underground. That ice can be melted, purified, and used for drinking, farming, and electrolysis, splitting it into hydrogen and oxygen for fuel and air. Scientists have confirmed you could theoretically extract enough water at that site to sustain a small colony. And for food, researchers are exploring aeroponics, growing plants in a mist of nutrients without soil. Cyanobacteria can fix nitrogen. Insects and lab-grown protein fill caloric gaps. It's not appetizing, but it's survivable. Nobody saw this coming as a headline problem, but it might be the hardest one. The human mind. A round trip to Mars takes roughly 2.5 years. During that time, there is no quick rescue. Communication with Earth has a delay of up to 24 minutes one way. So if something goes wrong, you can't call for help and get an answer in under 48 minutes. You are, for all practical purposes, alone. Studies from Antarctic isolation stations. The closest analog we have showed that long-term confinement in a small group triggers psychological breakdowns, depression, aggression, and what researchers call third quarter syndrome. People start deteriorating mentally about 3/4 of the way through an isolated mission. On Mars, that period could last months, and the gravity issue loops back here too. At 38% of Earth's gravity, muscles waste, bones thin, cardiovascular systems weaken. Astronauts on the ISS, where there is zero gravity, spend 2 hours a day just exercising to slow this process. On Mars at 38%, the degradation is slower, but still deeply unknown over years. Life support systems would need to recycle air and water with 95% efficiency. Every failure in that chain could be lethal. These aren't small engineering problems. These are civilization-scale challenges that we've never solved before. So why go? If it's this hard, this dangerous, this expensive, why? Here's the argument that keeps serious scientists, not just Elon Musk, up at night. Earth is fragile. A single large asteroid impact, a runaway climate event, a pandemic 10 times worse than COVID, these aren't science fiction scenarios. They are statistical certainties over long enough timescales. A species that exists on only one planet is always one bad day away from extinction. Mars represents what engineers call a backup drive for civilization. And there is a second argument. Every major leap in human capability has come from being forced to solve impossible problems. The Apollo program gave us integrated circuits. Space station research gave us water filtration technology that's now used in hospitals worldwide. Mars will force us to solve closed-loop life support, radiation medicine, food systems that work with minimal resources, technologies that will directly improve life on Earth. Nobody said it would be easy. Nobody said the first settlers wouldn't suffer. They will. But for the first time in human history, we actually have the hardware, the science, and the will to try. The question isn't really, can we go to Mars? The question is, are we brave enough to stay? We are living through the opening chapter of something enormous. Whether Starship lands in 2026, 2031, or 2040, humanity is going to Mars. It's not a matter of if, it's a matter of when and how much it costs us to get there.